In this video we'll be taking a look at how we can use multiple Dupont connectors and the best way to manage them when we need to connect and disconnect groups of them in one go. And if you've been doing this for a while, then you will be needing that at some point. We'll be looking at some of the techniques we can use, and I'll be introducing a plug type I invented to make this process much easier. So without further ado, let's jump in. So you've finally got your project working. You have all the right cables connected in all the right ways. You finish your testing. What a relief it is. Now of course you have to put your project in a project case, or perhaps rewire it to fit into something else. Well, that's where the problems begin, because you're going to have to write down all the colors of the wires, and of course you're going to have to write down the pin numbers they connect to, so that when you reconnect them, you get them all in the right place. What a pain in the butt. And I've been doing that for some time. That was the way I managed it, and I figured to myself that there has to be an easier way. So I tried a few techniques. None of them work properly, but I will go over them anyway because they may work for you. And ultimately I ended up inventing a plug so that I could do this manually and pull all the wires out together in one batch and put them all back in without having to make notes. So what we do is we'll cover the various techniques I use, and if any of those work for you, all good and well, and if they don't, then I'll show you how Pog plugs work. The first thing I looked into was an IDC connector. For this I used some ribbon cable and not the Dupont terminated cables. These clamp onto the ribbon cable using a special tool. Speaking of which, there are links to all of the tools and components I mention in this video in the description. As the name suggests, as the two parts of the IDC connector are clamped together, the ribbon cable's individual wires have their insulation displaced, thus making contact with the plug's pins. This is a quick and easy way to achieve a good connection. If you use this method, it is important to make sure that the cable is placed perfectly parallel to the plug so that the wires align with their respective pins, otherwise crossover connections may occur. I recommend that you trim off any protruding cable with a sharp knife, as the end of the wires will be bare, and this will help to prevent any accidental contact with other components and wires used in your project. In my case, using IDC connectors on a ribbon cable was not an option, as I was planning to connect my Arduino Giga with the Giga display shield. As these two units normally attach to each other back to back, this will not work, as using this method would effectively cross over the connections. Normally on such an IDC cable connection, connection A at one end would connect to connection A at the other end. However, in this use case, connection A would connect to connection B. So clearly, that isn't going to work for me. Ah yes, the old faithful hot glue. There are many uses for hot glue in electronics projects, from holding components in place to mounting LCD displays. It appears though that holding Dupont plugs together is not one of these uses. As can be seen here, when the plugs were pulled out, some of the pins misaligned. Also, slight lateral force caused the plugs to shift, which make them very difficult to reinsert. Clearly, this technique was not up to the task. As you know, cyanoacrylate adhesive is very versatile, but it just was not the right adhesive for this job. The plugs pulled apart with relative ease. Perhaps sanding them first would have helped, as they have a fairly smooth surface, but I cannot imagine doing that for 24 plugs. So no, this was not a viable option. Well, this is an interesting one. I watched a YouTube video by Loctite explaining the uses for their 406 adhesive, link in the description. I thought that I would give this a try, and I must say I wasn't disappointed. The pros for this product are: it has an extremely strong bond, it is easy to apply, it has a water-like consistency so it flows well, and because of this it does not overfill joins, and it dries very quickly. On the cons side, precise placement of the objects you are trying to bond together can be difficult if there is no method to align them first, as it dries very quickly. Due to its water-like consistency, it flows rapidly from the container, making spills difficult to control. Verdict: a fantastic product for adhering plastics and a must tool for every maker. Having said that, having weighed the pros and cons of this particular product, I do not think that it is suitable for adhering 24 pins side to side and back to back. So, this brings me to the reason I invented Pog plugs. It was born of necessity, as I could not find an existing way to group the Dupont connections easily and treat them as a single plug. This is what a Pog plug looks like. It has dimples which fit inside the Dupont connector's recess, which hold the connector firmly in place. The plug is aligned with the Dupont connectors, and the cover is then pressed against the plug, causing the latches to fit inside of the plug's recess, thus creating a sealed package. This now allows the Dupont connects to be removed as one unit. The plug can, of course, be reconnected. The plugs were designed using the 3D modelling software Alibri Atom 3D and printed on a Bamboo Lab H2D 3D printer. After weeks of research, I decided on ABS GF as the material to use, as it fitted with the precise parameters I laid out to ensure that the plugs worked as expected. The plug and cover were printed to very tight tolerances in order to fit the Dupont plugs from many manufacturers. I'm pretty sure that this is around the time I started to pull out my hair. The good news is you don't have to go through what I went through. I wouldn't wish that on anybody. You can get Pog plugs from my Ko-fi store, link in the description, or you can scan this QR code. See you soon and stay safe.